Welcome back to another tutorial. In today's video, I'll walk you through how to perform a flood frequency analysis using the USGS PeakFQ application. When sufficient stream gauge data are available, gauge-based frequency analysis is generally considered one of the most reliable methods for estimating flood discharges at that specific location. The reliability of the results depends largely on the length, quality, and representativeness of the gauge record. In the latest update, PeakFQ moved from a Windows desktop application to a web-based platform, so the analysis can now be completed directly through a web browser. PeakFQ follows the procedures outlined in Bulletin 17C, the current federal guidelines for flood frequency analysis. These procedures address historical information, regional skew, censored data, potentially influential low floods, and confidence limits. If you'd like to learn more about these procedures, I recommend reviewing the Bulletin 17C report. One key recommendation worth highlighting is the use of a weighted skew, which combines the station skew calculated from the gauge record with the regional skew to produce a more reliable skew estimate for the flood frequency analysis. Okay, let's get started. For this demo, I'll use the stream gauge on the Root River at Racine, Wisconsin. This gauge has a continuous record extending through the present, and later we'll compare our results with the estimates provided in the StreamStats report for the same gauge location. As you can see, PeakFQ has three options for importing annual peak flow data. I prefer the second option because all you need is the site number. Let's give the gauge data a moment to load. Once it's loaded, we need to define several inputs for this gauge. Since this gauge is in Wisconsin, I've pulled up a USGS report that provides the recommended PeakFQ inputs for Wisconsin gauges through water year 2017. This is helpful because we don't have to determine values such as the regional skew and its standard error manually. Otherwise, we would have to rely on some other studies. After downloading the input data, you can simply open the PSF file in Notepad and locate the input values for your gauge. Now let's copy and paste these values into PeakFQ. Since we'll later compare our results with the gauge-based estimates from the StreamStats report, let's keep the analysis period consistent, from 1964 through 2017. We can easily update the period of record by going to the View/Edit Site Data tab on the right-hand side. And as I mentioned earlier, PeakFQ follows Bulletin 17C, which recommends using a weighted skew for gauge frequency analysis. Let's copy the generalized skew and skew standard error values for this gauge into PeakFQ. You'll notice that the mean square error is populated automatically, since it is simply the square of the skew standard error. For the outlier threshold, I'm selecting multiple Grubsbeck. This helps identify unusually low annual peaks that could otherwise influence the frequency curve and distort our estimates for larger floods. Lastly, let's also turn on the urbanization or regulated peaks option so that our settings match the PeakFQ inputs for this gauge. Before hitting the Run button, let's briefly look at perception thresholds. A lower bound of 0 and an upper bound of infinity mean that floods of any magnitude could have been observed during that period. Perception thresholds help PeakFQ account for missing years, gaps in the historical record, and floods that may not have been recorded, reducing potential bias in the final flood frequency curve. Let's enter a name for the output file and then click Run Analysis. Once the analysis is complete, you can download the output folder as a zip file. The folder contains several files, but for the detailed flood frequency results, open the log file. For this gauge, the estimated peak flow at the 1% annual exceedance probability, or the 100-year flood, is 6,104 cubic feet per second. If you notice, the StreamStats report for any USGS gauge location also provides gauge-based flood frequency estimates. So let's compare our PeakFQ result with the corresponding value reported in StreamStats. If we open the StreamStats gauge page, we'll see several parameters. Let's scroll down, filter the stream flow statistics to peak flow, and locate the 1% AEP estimate. StreamStats reports a peak flow of 6,340 cubic feet per second, compared with our peak FQ estimate of 6,104 cubic feet per second. This small difference could be due to slight variations in the analysis settings, software versions, or rounding of the skew parameters used in the StreamStats analysis. Overall, it's fair to say that the two estimates are pretty close. Before wrapping up, let's quickly review the shape of the frequency curve. Here, the fitted curve is smooth, with no unusual bends, and the observed peaks generally follow the curve. The confidence limits widen toward the less frequent floods, which is expected due to greater uncertainty. Overall, the frequency curve looks reasonable, with no obvious concerns.